So, and then let's talk about this part. Chain rule. So before we talk about the chain rule, let's recall what we studied before. So if we have a function of one variable, right? And then we have another function, this is gt, right? We can consider a new function. This is a composition of f with g, right? The theorem we studied before is the derivative of t is f gt, the derivative, and multiplied by the derivative gt. So it's kind of, you may say, chain rule, right? Specifically for Americans, because you know the chain, right? Because this is the English. You know, chain, you can think about the food chain, right? Always from the top to the bottom, right? And you can say we have, finally, first we have a function f, right? The value is this, and then we have a g, it's the variable of t, right? Now we have a function of t, this is f and gt. Now, if we ask you to compute the derivative ft, you have first differentiate x. That's why you have the derivative of gt, right? And then you go down to t, because you have to remember we are differentiated t, right? So, and then we have go this. So let me give you an example in case you forget it. So now we have a function ft is e y, and y is x squared. Of course, you can say for this example, why not just write the fy? Fx is ex squared, and then let's continue compute this ex squared and 2x. Yeah, if you write it there in this formula, you still use that. You have to remember it. So let me think it in my way. We have fx is ex squared, right? So you first differentiate f. You have to remember you are differentiate at x. So first, there is an outer function e. We know for ex, the derivative is self. So just it's self, right? This is kind of the outer one. And then you have to differentiate the inner function. It's kind of ex squared 2x. So it's kind of, you are, peeling an onion, right? You from outside to inside. You may say, okay, we may try another way. You just memorize this formula. You use this f x is e x y, and y is x squared. You first, this is f. You compute for fx, and then you evaluate at y, right? And you compute the derivative of y. So the derivative fy is e y, and the derivative of y is 2x. This is just a plugging in substitution, ex squared 2x. So the answer is 2x ex squared. Anyway, no matter which method you choose, the final answer should be the same, right? No more talk about this part. Okay, just give one more. Okay, in case you forget it, we have f x is sine x, and x is e t. So let me write it out. F t is sine x is e t. Let's first compute t. This is the outer function for sine. Just look at this as a whole. We get a cosine e t, but not done yet. because we're differentiating t, you have to differentiate this again. So we get a cosine t, and et is t, right? So the answer is et cosine et. Okay. So if you okay, maybe I'm too worried about you. If you don't know this, check the previous book. Okay, and try to get the answer. Okay, and then today let's talk about the chain rule for function with the two variables. Okay, come back to our materials. Okay, come back. Now we have a function f. Let me check. Maybe this is case one. Case one. We have a function f x y have two variables, right? So we assume x is a function of xt. Okay, just write gt maybe. Y is a function of ht, and then we can plug in x, y by gt and ht. So we get a new function ft, right? Or you write zt, it's the same, is f gt this ht. So the question is, now you get a function of one variable is a function of single variable. So ft, the formula tells us, okay, ft is partial fx evaluated at gt, ht. Like I said, this part is very important. Okay, plus gt and plus fy evaluated at gt, ht, and ht. So let me draw a picture for you. So this is f, or z is f, right? It's a function of x, it's a function of y, and x, y are both a function of t, right? You want to compute zt like this, right? Zt is just no, dz, dt were above ft, they're the same. All of this notation were used before. So if you want to differentiate t, you have two ways to come here. This one row, second row. So we have fx, and but here x is written as g, right? You write g, this is h, and g plus fy h. But here you have to be careful, because finally it's a function of t. This is evaluate at gt, ht, gt, ht. Okay. So you may say, when you are doing a problem, you may say, if we still have x and y, what will happen? You just replace your x, y by gt and ht. Okay. So this is about the chain rule. For the first, it's kind of the first type chain rule. Okay, let me go more. We have many types of chain rule. Okay. Case 2. Still, we have a function f, x, y. X is a function of g, st. Y is a function h, st. And then we have a new function with two variables. This is f, g, st, and h, st. So first, you can say, if we ask you compute fs, so we can, let's first analyze it. We have z, this is f, it's a function of x, y, and then we have s, right? So fs should be f x, x is g s plus f y h s. You go this way, and you go this way. You add them together. Okay, this is fs, and then ft. We draw same picture. Z is f. We have x. This is y. This is t. So if you compute ft, first you compute f x and xt, because this is g, this is h, this is ghs, gt plus fy ht. So this is the second type of chain rule. We only have two types of chain rule, right? But you may, here I still want to emphasize, this is evaluate it at gh, but gh is determined by st. Okay, let me just show you an example. I don't think just, I explain it and then you can understand it. But my search, just you need a very specific example. Okay, just I show this example and then we can end today. So now we have z is ex sine y, right? X is st, y is s squared t. So the question is that please compute zs and zt. So let's first compute zs. If you compute zs, you have to first go zx, and for x you have to go differentiate s plus zy and y differentiate s. So after we know this, means you have to compute this, right? And compute this. So let's first compute xs. xs is t, ys is 2st, right? And then let's compute zx. zx is ex sine y. zy is ex cosine y. But finally, only s and t can appear in this problem. So means that you have to, but here you still have x and y. If you plug in this into the final result, I cannot say you are wrong, but you just didn't finish this problem. Here we don't have x and y. You have to replace your x by st. Sine y is s squared t. ex st cosine s squared t. Finally, zs is est sine st squared. xs is t plus est cosine s squared t plus 2st, where you can write it better. est and sine st squared and t plus 2st cosine st squared, right? So by the same method, you can compute zt. zt is same method, you know, zx xt plus zy yt. But you know, we already computed this part by the first one, right? You know, when you are doing a problem, you know, test them. So you have to, you know, don't compute it twice. Or you can first compute zx and zy. Okay, you don't have to compute it again, but we have to compute the xt. Xt is s, yt is s squared. You plug in this, zx is est. Okay, sine s squared t plus xt. Xt is s plus zy is est cosine st squared and yt is s squared. So we write the est s sine s squared t plus s squared est. So finally we get no zs is est s sine s squared t plus s squared. Sorry, I made a mistake here. I think cosine s squared t cosine no 2st cosine st squared t zt is est s sine st squared plus s squared cosine s squared t. So chain rule is very important. I think you have to get some practice about the chain rule. I think that's all for today's class. If you have any question, you can ask me, or if you want to leave.